Hey everyone, and welcome to The Explainer. Today, we're zooming in on what is literally the most valuable, bustling piece of real estate off our planet, low Earth orbit, or LEO. It's where human spaceflight happens, where our weather is tracked, and where the modern internet is increasingly being beamed from. Honestly, understanding this specific region of space is absolutely crucial to understanding the future of our entire planet.
To get a sense of just how wild this neighborhood actually is, let me ask you a question. Where can you see 16 sunsets in a single day? Well, the answer is right above our heads. You see, a satellite operating in low Earth orbit moves so incredibly fast that it completes an entire revolution around the Earth in just 90 to 120 minutes. Depending on its exact altitude, that means it's circling the globe 14 to 16 times every single day. Just imagine experiencing a sunrise and a sunset every 45 minutes. It's mind-bending.
Okay, let's dive into this structured tour of our orbital metropolis. First, a welcome to the neighborhood. Then we'll check out the perks of the zip code, unpack the cost of doing business, and finally, look at some famous residents and the future.
Section 1. Welcome to the neighborhood. Basically, this is the very first orbital region reached by most launch vehicles right after ascent.
So, here's a quick cheat sheet of LEO's core parameters. It's defined as the region ranging from about 160 kilometers to 2,000 kilometers above the Earth's surface. That means this entire zone is essentially an 1,840-kilometer thick shell wrapping perfectly around our planet. Because it sits so perfectly close to Earth, the communication delay is incredibly low. We're talking under 10 milliseconds. But you know the most staggering number here? It's the orbital velocity. 7.8 kilometers per second. That is the strict speed limit required just to maintain a stable circular orbit in this neighborhood. To put that into perspective, that's roughly 17,500 miles per hour. If you aren't traveling at that precise, massive speed, you simply cannot live in this zip code. But why is that?
And this brilliantly illustrates the physics of it all. You see, a satellite doesn't just peacefully float. It's locked in a high-speed cosmic balancing act. Because LEO is so close to Earth, our planet's gravitational attraction is incredibly strong. To avoid crashing back down, the satellite has to move forward at that staggering 7.8 kilometers per second. At this velocity, it's continuously falling toward the Earth, but it's moving forward so fast that the Earth's surface curves away beneath it at the exact same rate. That forward velocity perfectly balances the gravitational pull.
Moving right along to Section 2, the perks of the zip code. Let's look at why everyone wants to set up shop here.
If you literally have to travel 17,500 miles per hour just to stay there, why is LEO the prime real estate for almost everything we do in space? Well, it comes down to a few massive advantages. First, the views are gorgeous. Being this close means you get high-resolution imaging for environmental monitoring and military recon. Second, it's a remarkably cheap commute. Reaching LEO takes way less energy, meaning smaller launch vehicles and more payload. Third, easy access. Astronauts can reach this orbit in just a few hours. And finally, that incredibly low communication delay.
I want to zoom in on that communications perk for a second because it's a real game changer. Since LEO is basically right next door in astronomical terms, signals travel a much shorter distance. This drops the latency down below 10 milliseconds. This specific feature is exactly what makes fast broadband and high-quality video possible, and it's the whole reason modern internet satellite constellations choose to operate here.
All right, Section 3, the cost of doing business. Time to look at the hidden taxes of living in downtown space.
Being so close comes with some serious limitations. The first major one is your field of vision. Because you're so close to the planet, which gives you those great high-res images, you can only see a tiny portion of the Earth at any given instant. It's kind of like standing an inch away from a massive painting. You see the details, but you miss the big picture entirely. Because of this restricted view, companies are forced to launch massive fleets or constellations of satellites to cover the whole globe. Then there's the physical tax, atmospheric drag. Space isn't a perfect vacuum, right? Especially not at 160 kilometers up. There are residual atmospheric particles floating around in LEO. So when satellites hit these particles at 7.8 kilometers per second, it creates a physical drag. It sets off this domino effect where the orbital altitude gradually decreases, reducing the satellite's lifetime. If you don't perform costly, periodic orbit maintenance, well, it eventually results in a fiery atmospheric re-entry. So, visualizing these four major hazards, we've got the limited coverage, that constant atmospheric drag, and frequent handovers. Since satellites fly over ground stations so fast, you only get a few minutes of connection per pass. But the most critical hazard? Without a doubt, it's the higher collision risk.
LEO hosts thousands of active satellites and tons of space debris. In this super dense environment, active collision avoidance isn't just a nice idea, it's absolutely essential.
Which brings us to Section 4, Famous Residents and the Future.
You might be surprised to realize just how deeply this specific orbital neighborhood impacts your day-to-day life. Let's tour some of the famous landmarks floating above us right now. The International Space Station, a LEO resident. The legendary Hubble Space Telescope operates here. Environmental monitors like the ESA's Sentinel satellites, and massive broadband networks like Starlink all call LEO home. Literally, every time you check a weather app or use satellite broadband, you are directly interacting with this exact neighborhood.
Now, what's really interesting about this slide is the sheer intensity of the engineering required to survive up there. Designing a spacecraft for LEO isn't just about putting it on a rocket. You have to protect it against atomic oxygen, which can actually erode the spacecraft's materials. You need robust thermal control because, remember those 16 sunsets? The spacecraft is rapidly plunging into freezing darkness and then back into blistering sunlight every 45 minutes. Throw in radiation-tolerant electronics and constant drag compensation, and it's a wildly hostile environment.
But it all boils down to this perfectly synthesized takeaway. Low Earth orbit provides an excellent balance between accessibility, mission performance, and operational cost. Despite the drag, the extreme thermal cycling, and the crowded conditions, LEO just hits the absolute sweet spot. It remains our most strategically important region for both government and commercial space activities.
But that massive strategic importance brings us to a critical crossroads. As we continue to launch thousands of new satellites, low Earth orbit is rapidly becoming our most crowded highway. That collision risk we talked about, it's only increasing. So I want to leave you with this lingering thought. As this prime real estate becomes increasingly packed, how will we manage the traffic of tomorrow? How do we enforce space debris mitigation to protect the neighborhood that connects and monitors our modern world? It's a huge challenge that engineers are racing to solve right now. Thanks so much for joining me on this explainer, and keep looking up.